Hey there, this is László Marcel, aka the Tinker Dad. First of all, let me wish you a happy new year because, well, this is this channel's first tutorial video in this new year. In this video, I will show you how I run Docker containers on Proxmox. So if you're interested, keep on watching. But first, if you're a new visitor to the channel, welcome. On this channel, we deal with home automation, home networking, and sometimes with related stuff like DIY electronics and even a little bit of 3D printing. Anyway, let's continue with today's topic. Let's start with the funny thing. So when a newcomer first uses Proxmox, probably he or she will be interested in what can you run on Proxmox. And LXC containers and VMs are obvious, but the question arises, can you run Docker containers? So as those are not present on the UI, he or she will just start Googling and eventually will end up at this document. And then this is the FAQ document of Proxmox, and it's not a long one. And the last point details what can you run. So you can run LXC, LXD, containers, Proxmox containers, Docker containers, or can you? So it clearly says it is not recommended to run Docker directly on Proxmox VE host. Also it says if you want to run Docker containers, you can just use a VM and run those containers inside. That is pretty easy, pretty obvious, but probably not the most resource efficient solution. So if you think about it, Proxmox is just a glorified Linux distribution. It clearly says here it is based on Debian, and Debian is pretty much able to run Docker. So technically you can run Docker containers on Proxmox itself, but before doing so, let's dig deeper into this. So there are pros and cons here that you should consider before jumping into things. So when we are talking about running something on Proxmox, it can mean a couple of different things. So it can be an LXC container, it can be a VM or something running inside a VM. Or actually, it can be something that is running on the operating system that is under Proxmox, Debian Linux in this case. So in this situation, we are not really running stuff on Proxmox, as in it is pretty much running besides Proxmox on the operating system, but it's still doable. And Proxmox, in fact, can help you with doing that. But you must note that if you run something besides Proxmox, it will be pretty much invisible to Proxmox itself. I mean, you have the resource monitor, and you will see that something is eating up your RAM or eating up your CPU time, but these infos are coming from the underlying operating system, and Proxmox will not be able to tell you that this is this or that container or whatever you run. So technically you can even run your own services on top of Debian besides Proxmox, but Proxmox will have absolutely zero control over those. And this applies to Docker containers as well, because Docker daemon is a service running on the operating system. This also brings one consequence with it. So when you are using Proxmox in a cluster, you are able to migrate different VMs between different nodes of the cluster. If you are running something on the host operating system outside of Proxmox, you obviously lose this capability. So unless you use something like Portainer to manage your containers, you just start those on the host operating system and they will be running there. And you won't have too much control over them. Obviously, you will have the command line. You can log into the host operating system, you can start and stop containers and restart them and so on, but pretty much that's it. Again, the whole thing will be invisible for Proxmox, besides the resource usage, obviously. So if you are okay with these terms, Then we can jump into the action and we can install and run Docker, and with it your containers, obviously. So let's start with that. As I mentioned before, Proxmox is running on Debian Linux, so the official documentation of Docker considering the installation on Debian Linux part should work, although a few modifications are needed. So we will just mostly copy paste the commands, but some are not needed. For example, you don't need to care about old versions because you don't have that. Also, we will be installing with repository, but you don't need to care about this first apt-get update command because Proxmox itself keeps the operating system up to date via its automatic package updates. So we will just start here. You also don't need a sudo because if you are logged into Proxmox, it's via the root user by default in this shell. So we will just issue this command first, and then we will do all the rest without sudo, of course. So let's get started. Normally this whole process shouldn't take long, and I also copied the modified commands into the description of the video. Please note I also sped up this part to stop wasting too much of your time, so if you just want to check out the output of some of the commands, then feel free to pause. And that's it. As you can see, we have successfully executed a simple program running inside Docker on the Debian Linux that is running also our Proxmox installation. Now, I understand for many of you this isn't the solution, just as I explained at the beginning of the video. So what else can we do? Let me show you something else, a different way. Okay, so let's assume the following situation. You don't really want to expose your whole Proxmox host to those containers because you know those are running against root processes. But you don't really like the idea of a full-blown VM either, because those eat up a lot of resources to virtualize the whole operating system and of course the underlying virtual hardware. So what can you do? LXC containers are here for the rescue. So I admit that it might sound a bit weird to put containers into containers, but trust me, it works and it's quite easy. So especially with UI support for this, creating a container, an LXC container, is quite easy. So we will just quickly do that, and after that I will explain how these work together with Docker. Setting up an LXC container within Proxmox is quite easy. It's just as easy, if not easier, than setting up a VM. So just like for a VM where you need an ISO image, here you will need something that is called a template. So templates are stored on one of your storages. So you just check your storages and look for one that has this section called CTE templates or container templates. There you can see different templates with different operating systems, or in case of a totally fresh installation, these should be empty. So when you click templates here, you can search and install existing templates. In case of a Docker host, I usually use Debian or Ubuntu. This time we will go with Debian Buster, because why not? So I can just select that, click download, and it will take a few seconds to download that small template. And when it says task OK, I can close this one. Now, based on this template, I can create a container now. So I just select the node, then click Create Container. Here I have to set a few options. So password, this is for logging in to your container via SSH. So I just quickly add the password. Hostname will be the name of your container, and within the container the operating system will actually see this value as a hostname. So let that be test_ct. Now a container can be privileged or unprivileged. Privileged containers can do more stuff, but can run malicious code more easily. So it always depends on the use case whether you want to use an unprivileged or privileged container. In case of Docker, some privileged features are needed. So you can either go with unticking this and having a privileged container, or you can leave it as it is, and in that case we will need to set some options later on. Okay, since I prefer to have the privileged container, we will go the second way. So leave it as it is and click Next. In case of template, here you select the template you have just downloaded. So I select that Debian one. Once again, I click Next. Root disk. This is the disk where the operating system within the container will reside. Now, in case of containers or LXC containers, you can mount local folders just like you can do it with Docker volumes. So you don't need a huge virtual disk. Instead, we will just mount some folders from the host. So I will just leave it on the suggested 8 GB. This will do nicely as the base operating system storage. Other than that, I can leave all options as they are. So click Next. Here you can allocate some CPU cores. I set it to 2, and in case of memory, I just will set it to 2 gigs. In case of network, I select DHCP because right now I don't want to bother with setting up IP address and gateway and whatnot. And since this installation is a pretty standard one, I don't need to change anything with the network here. Okay, DNS is just fine. The host is set up to use my Pi-hole as a DNS server, and that should be also set up to have a DNS domain, which is in my case looks like hostname.lan. So I click Next, and the confirmation dialog just shows you the values you have previously selected. You can click Start after created here to have your container instantly up and running, and you can click Finish. So this will take like roughly a second or a minute or something like that to extract the template, set up that small virtual hard disk, and then when task OK appears, you can close this one. Okay, as you can see now we have our container up and running. So in theory, you could use the container right now to issue Linux commands. However, as you can see, the console is empty. I mean, too empty. So this looks like a bug. It happens from time to time with different Linux distributions, and I couldn't really find out the reason, nor all those people on Reddit and various forums. They just keep reporting it, but it's still happening. Anyway, there's a workaround for this problem. So you just go to Options and select Console Mode and double click here and make sure that you, instead of the default, you select Shell. Now click OK, and here you reboot the container. So this will take like 2 seconds or something like that, and when you go back to console, you can see now that the console is available, and voila, you can issue Linux commands on your running LXC container. Now we are almost ready to install Docker. As I mentioned before, to execute Docker within an LXC container, there is a slight adjustment we need to make our container to make Docker work. To do that, you need to go to shell once again, but not to the shell of the container, but instead to the shell of the Proxmox node. So you select it, you go to shell, and then we will look for a file with an editor. So let's use Nano, then, or you can use VI or whatever editor you have at hand. Then it should be etc pve, which is for Proxmox, then local, that is the storage where the container resides, and then it should be lxc, and after that there should be the ID of your container. So in our case it's 100, so I just say 100 and .conf. So this is a file, and you need to add a single line which looks like the following. Okay, so this is quite simple. After that, you just save the file and restart your container. And now you can proceed with installing Docker, and the steps are pretty much the same that we have used when we installed Docker on Proxmox itself. So first of all, we will just reboot the container. Now that the container is up and running, we can start with updating and so on. In case you run into this kind of problem, it is because Debian Buster is a bit old. So there's a solution for that. Actually, you just need to add an extra parameter for the update command. This parameter will instruct apt to accept any updates made to the repository since the last update. As you can see, now it's working, and at this point we can do the exact same commands. So let's just do those quickly. As a quick reminder, these are the commands we have used during the normal Debian Linux installation, and again, these are the ones that you need to execute in the same order. Please note that the test command that was the last one in the list is missing from here because to test an LXC container we will use a different command. Instead of the regular hello world Docker container that is normally used to test a Docker installation to see whether it's working, we will be using netdata. So netdata is a quick and lightweight analytics tool that attaches itself to your system and grabs a lot of information about your CPU and memory and network and whatnot. And yeah, it's a useful tool, but the point is that if you're able to run netdata now, then there's a high chance that pretty much any other container will just run fine. So it actually proves us that our Docker installation within an unprivileged LXC container is working fine. Obviously, if you don't like the idea of testing with netdata, you can use any container that comes into your mind, and you can just alter the docker run command or even install Docker Compose and test to your liking. As you can see, that long command to download and start the netdata Docker image as a container, it succeeded. We can check it with Docker PS. It says it's running, so we need to try whether it works actually. So first I'm just fetching the IP address of the LXC container. It should be this one, which is a DHCP allocated IP address, and I will need to use the port for netdata. That was this one. And as you can see, it's up and running. Now let's take a look on Proxmox again to see the resource usage. And as you can see, it uses a little bit more than 10% of the allocated memory. It's a minuscule amount of CPU, and mind you, this is only a fraction of the actual system because we only assigned 2 CPU cores to this LXC container. And as you can see, for running netdata, we could actually gone much lower with the memory, with the disk size, with the CPU as well. It's worth mentioning that NetData doesn't use data on the disk, so this is why the very low disk usage. But for example, if your container needs to access a set of folders because it reads data from somewhere, or actually it needs to write some data like downloading stuff or writing to database, then you will need to connect storage from your Proxmox node to your container, and this is done via bind mounts. So let's take a quick look at bind mounts as the last part of this video. Working with bind mounts, it's quite easy. So first of all, you need to go to your Proxmox host, to your node, and assuming that you don't have a folder yet that you want to mount up to be visible and accessible from within the container, you need to create one. So let's say I'm creating a folder called /media/folder. Okay, yeah, it's already exists, whatever. That will be the one that what we mount up into the container. So now I need to edit the configuration file of the LXC container once again. Here I need to add an entry that will map the folder to another folder inside the container. So this is the name /media/folder, and this is the name that will exist inside the container. So now I need to save this, exit, and restart the container. So I just clicking reboot here. Yep, I want to reboot it. While it reboots, I go back to Proxmox for a second. So when it comes to write access to those folders, it comes a little bit complicated, because from the operating system's point of view, the container is running under a separate user. So that means the user does not have write access, and so doesn't the container either. So it means that you need to give write access on that folder. Right now, because this is not the central part of this video and I don't want to waste time on explaining this, I will just do a quick hack and basically say that I want that folder to be writable by anyone. So I'm just setting 777, which is like the God mode on a folder. And this is once again done on the Proxmox node. So now anybody can write into that folder. Now I go back to the container which rebooted while we done that, and go to, yeah, I'm at the console obviously. So now just let's see the folder. Yeah, it's there. So I'm using the touch command to create an empty file. Let's say hello.txt. The command succeeded and now the file is there. So I go back to Proxmox and let's see if I can see the file. Woohoo, that's it. So basically now we can write into a folder that is located on the Proxmox host. Within the container, you can mount this folder into your Docker container with the usual -v command parameter. So that's it. It means that you can run Docker containers within Proxmox, within LXC containers, and those can write to a system folder, those can access resources, and yeah, mission accomplished. Okay, actually this topic, it could be really long, much longer. I could talk about this topic for hours, explaining the nitpicks of this folder management, these access rights, and what else you can do, but I really don't want to make the video any longer. So let's conclude this for now. If you have questions, use the comments as usual, and I will be happy to answer those. So, as you have seen, most of these solutions are pretty hacky, and if you keep wondering whether Proxmox is the right tool for you to run Docker containers, you are absolutely right. In my personal opinion, if you heavily rely on Docker containers, then you might be better off with something else. But still, Proxmox is there to use if you want to run a mixed solution like a couple of VMs, a couple of containers, Docker containers, whatnot. So there you go. Anyway, before summing up this video, let me ask you a question. How do you run software on your setup? So what's your story with Proxmox, with your containers, with your VMs? Because, well, I'm also learning and I'm curious about how other people do stuff like that. So if you have anything to share, please use the comments. And while you are at it, if you haven't subscribed to the channel yet, please consider subscribing. It helps me a lot, and you will also get notified when I upload new videos. So anyway, thanks for watching this, guys, and hope to see you next week, next time, with another video. Bye.